Welcome to lecture 1 on module 2 of 8051 microcontroller, in which we will be discussing about the addressing modes. In this particular slide, we will be discussing about the addressing mode. In case of 8051, we know that the data or the address are stored in memory. It may be a RAM or ROM. The memories can be, we have two types of memories that are supported by 8051, that is RAM and ROM. The data are stored in either RAM or ROM. For a CPU, in order to execute the instructions or in order to process the data, the CPU has to fetch the data from the memory. It may be, the memory can be either RAM or ROM. The data has to be fetched either through the register, or it can be provided as an immediate data, or the data can be fetched in the form of direct memory. So based on this, we have 5 different types of addressing modes: immediate addressing mode, register addressing mode, direct addressing mode, register indirect, and indexed addressing mode. The detailed discussion on this will be done in the coming slides. In this particular slide, we will be discussing about the immediate addressing mode. In case of immediate addressing mode, the number that represents the source operand is directly loaded into the destination registers. In case of immediate addressing mode, it is represented by a special symbol called pound, where whenever there is a instruction in case of source operand is preceded by the sign, pound sign or hash symbol, what we call, then such kind of addressing modes is called as the immediate addressing mode. This, in case of immediate addressing mode, it has the capacity to load the information into any registers, including the 16-bit DPTR registers as well. DPTR means the data pointer register. If you look into some of the examples here for immediate addressing mode, we have move a hash 25h. We know that a represents a memory location, address of some memory in RAM. Now when you execute this instruction move a hash 25h, the address represented by a will be loaded with the data 25h. Similarly, in case of move r4 60 hash 62h, r4 register will be loaded with the value 62h. In case of third instruction, it is move b hash 40h. It will load 40h. It will load the data 40 into the address represented by the register B, or we can simply say that B register will hold the value 40h. Similarly, in case of data pointer register, which is a 16-bit instruction, whenever you use move dptr hash 4521, the data pointer register will be loaded with the value 4512h. We know that the data pointer register can be split into two 8-bit registers as DPL and DPH. Even the DPL and DPH registers can be loaded with 8-bit data using immediate addressing mode. Whereas in case of see here, we have a last instruction move dptr hash 68975. This is illegal because the value is greater than 65,535. So the maximum value that you can represent using 16-bit is FFFF. FFFF. Anything above FFFF cannot be loaded into a 16-bit register. That is why it is a illegal instruction. Move dptr hash 68975 is a illegal instruction. Here, if you look into one flow of a program, we call it as pseudocode. If you call it as a pseudocode, here count will be equal to this is a assembler directive. We have already discussed in module 1. This EQ is assembler directive. So what it does is it loads the integer number into count. Wherever you want to use this number, instead of the number you can use the count. So what we will do is move r4 comma hash count. What it will do, see here, what is the value now? The value of count is 30. So what happens is immediate value 30 will be loaded into the register r4. After the execution of this instruction, r4 register will be loaded with the immediate data 30h. Next, move dptr comma my data. See here, my data is a label. This is a label. So the label represents some address. The label represents some address, and in that address we have a my data as an address. It is a byte that is defined, and America is the string. Now move dptr comma hash my data. Here the dptr value is 200h. That will be loaded into the immediate value. My data will be loaded into dptr. So based on the corresponding instructions here, these values will be loaded. It depends on the application what we have. This org is one more assembler directive that defines the origin, or the from which location exactly the program starts. That will be represented by org. Next, one more instruction what we have is we can even use the immediate addressing mode in port. Here P1 represents port. We have P0, P1, P2 and P3 as the ports in case of 8051. We can use the immediate addressing mode. We can load the immediate values into the port, any one of these port, using this particular syntax. This is how the immediate addressing mode works. In this slide, we will be discussing about the register addressing mode. In case of register addressing mode, the data has to be manipulated is loaded into one of the registers. The one important point that we need to note in case of register addressing mode is that the source register and the destination register size has to be matched. For example, if I consider the syntax as opcode comma source, so destination register comma source register, this will be the syntax. There is a opcode, destination register and the source. So in case of destination register, so it can be opcode or mnemonic. So here the size of the destination register, for example, if I consider the example of this particular instruction, the size of A register and size of R0 register has to match. In this case both are of 8 bit, so it is not an issue. For example, if you are using one as 16 bit and one as 18 bit, it is not possible in case of register addressing mode. So here in case of 8051 we have the registers R0 to R7. So we have 4 such banks. If the data are transferred, the data to be manipulated is transferred using any one of these registers, then such kind of addressing are called as register addressing mode. In case of the example here, move A comma R0. A is the destination operand, R0 is the source operand. For example, if I have the instruction move R0 comma hash 10h and then move A comma R0, in this case, after execution of these two instructions, after execution of the first instruction, this is immediate addressing mode, the value of R0 is 10. If I use this instruction, that is register addressing mode, move A comma R0, the content of R0, that is 10h, will be loaded into the accumulator A. After execution of this instruction, the value of accumulator will be 10h. The content in this case, the content of accumulator is copied to R2 register. In this case, add A comma R5. Add is a mnemonic to add two numbers. So ADD A comma R5, this adds the content of accumulator A and R5. Add A comma R7. See here, for example, A is 10 and R5 is 5. After this, you have an instruction add A comma R5. Then the result, after execution of this instruction, the result will be in accumulator, that is 15H. 15H will be present in the accumulator. In case of add operations, the destination value, the content of the destination value gets replaced by the result. This will add the content of A and content of R7. Move R6 comma A. Here the content of accumulator will be copied to the register R6. Here in this case, move dptr comma hash 25f5h. This is 16-bit register, so the destination register is also 16-bit in size. Whenever I use dpl and dph, move r7 comma dpl, move r6 comma dph. This is of 8-bit size. Both the source and the destination registers are of 8-bit size, so it is valid. Whereas this instruction move R4 comma R7 is invalid. In case of register addressing mode, the transfer of data between two registers is not allowed. Transfer of data between two registers is not possible. So accumulator has to be involved in most of the register transfer in register addressing mode. One of the registers will most of the times will be accumulator. In this particular slide, we will be discussing about the direct addressing mode. In case of direct addressing mode, we will be specifying in the instruction itself, we will be specifying the address instead of representing the data, as compared to our previous two addressing modes where we had immediate addressing mode and the registered addressing mode, where one of the operands had the data in it. Whereas in case of direct addressing mode, the destination operand will the destination operand will not have any data that has to be transferred. Instead, the destination operand specifies the address where the data is located. So that is the major difference as compared to the direct addressing mode and the other two addressing modes, immediate and registered addressing mode. In both the registered as well as immediate addressing mode, the data is present in the operand itself. For example, if I consider move a comma hash 10h, the 10h is the data that has to be transferred to a, whereas move r0 comma a, the content of a will be copied to r0. Whereas in case of the direct addressing mode, which is represented by move r0 comma 40h, neither r0 will have the data nor 40h will have the data. This 40h specifies the address where the data is located. So what happens is, when this particular instruction is executed, we have an address called 40h. In the 40h, we will have some content, for example 99h. This 99h goes and stores in r0. So this is how the direct addressing mode works. The most beautiful thing in case of the direct addressing mode is that you can transfer the data from any memory location to the other memory location. There is no, as such, there is no restriction as compared to the register addressing mode, where you cannot specify two registers in a single instruction. Here, by specifying the address, you can transfer the data between two different registers in a single instruction. For example, if we consider move r0 comma 40h, this 40h is the address, 40h is the address. Now the data that is present in this address, the data present in this address will be copied to the register r0. Similarly, if we consider the other instruction move 56h comma a, move 56h comma a, here This is the destination address. So the data that is present in A goes and sits in the destination address. For example, 56H. Now if we assume that A is equal to 10H, that 10, after execution of this instruction, the 10H goes and sits in the address pointed by 56H. So this direct addressing mode is most oftenly used to access the RAM locations from 30H to 7FH. We know that in case of RAM, the address starts from 00 and it goes up to 7F. Most of the times the address ranging from 30 to 7F, we are using the direct addressing mode. It doesn't mean that we should not use the direct addressing mode from 00 to 2F. We can use, but here we have all these are referred by some names, some registers and bit manipulation instructions. It is easy for us to use the name. If there are some issues, we can directly even access these memory locations using the direct addressing mode. The entire 128, that's what it says here, the entire 128 bytes of RAM can be accessed, that is from 00 to 7F can be accessed using the direct addressing mode. The register bank locations are accessed by the register names. See here, if we consider, we know that 0 to 00 to 1F we have registers. We have the register banks R0, RB, RB0, RB1, RB2, RB0, RB1, RB2, RB3, starting 0 to 7F and so on, it goes up to 20. Right now, even this has some names. Each memory locations has some names. It can be either accessed by R0 or it can also accessed by the address directly. Both the things are possible. For example, if we consider move a comma 4, this means that the content that is present in the address 4, content that is present in address 0, 1, 2, 3, 4, content that is present in the 4, let me take 100H. The content that is present in the 4 is nothing but R0, R0, R1, R2, R3 and R4. So 4 address, the address 4 is also nothing but R4. So when you use the instruction move a comma 4, the content that is present in 4 is copied to accumulator. That is, if I consider this as example, move the 4 address has the data 100H, the 100H will be copied to accumulator. The same instruction can be written as move a comma R4. What it says, the content of register R4 is copied to A. What is R4? R4 is nothing but, the address of R4 is nothing but 4. So these two instructions are one and the same. You can either write it as move a comma 4 or move a comma R4. Both are one and the same. This is what I said. Instead of using the register names, we can access the address. We can access the registers using the address. You see here the address of R4, this is name of the register, whereas this is the address of register R4. We can access the registers using their address. This is the beauty of direct addressing mode. By this we will complete the lecture 1, in which we have discussed about 3 different addressing modes. The rest of the addressing modes will be discussed in L2 of module 2. Thank you.